And we can also add and subtract vectors using unit vector notation, which is sometimes a little easier than making a chart. So this is really the point of having that unit vector notation. It makes the math easier and prettier and more organized. But just a couple of things to remember about vector addition. So let's say we have vector A and we have vector B. If I add A to B, right, then I'm going to add them tip to tail. So I could draw A, and then I could draw B, and this would be my resultant. If I subtract them, I'm really adding the negative of B. And the negative of B is this direction. So if I wanted to add those, I could go, here's my A, and I'm going to add negative B, exactly the same length in 180 degrees direction. And so this would be my resultant. Puts it in a resultant in the first quadrant. Whereas before it was, and looks like it was probably in the first quadrant as well. I'm not really sure. And then also I could do something crazy like this. So B, 2B would be pointing in the same direction, but it would be twice as long. So I would add A, and then I would add 2B, and its resultant would be here. Okay? So whenever you have a coefficient, you just multiply that vector's length or its coefficients by that coefficient, or its x and y components. So we could make a chart for all of these if we had numbers, and we could find the x's and the y's, but let's just do it like this. So let's say that we go back to our problem that we had before. We're going to add all those forces. We could write them in unit vector notation. So let's call this vector A. Oh, wait a minute, sorry. Vector A and vector B. And let's say that I want to add A plus B. Well, A is 200I plus 0j. I don't really have to write that 0, but I'm doing it as a placeholder. And vector B is negative 10.3I plus 28.2j newtons. So to find C, I just add these two together and I get negative 193 newtons in the I direction plus negative 230 in the J direction. So now I have my X and my Y, right? This is my X and this is my Y. And I could use R squared equals X squared plus Y squared to find the magnitude. And I can easily see that this has got a negative X and a negative Y, which means it's down in the third quadrant. So when I find tan theta, right, because it's in the third quadrant, I'm going to have to add 180 to it to get the polar heading. So I think this is a little prettier. It looks a little prettier to me, and it's the reason why we learn it is because it makes organizing, adding large quantities of vectors easily. So I've got two vectors here. I've got A is 20I plus 30jm, and B is negative 100 plus negative 60jm. So if I want to add A plus B, it's just going to be equal to 20 plus negative 100 in the I direction plus 30 in the j direction. So 20 plus negative 100 is negative 80 I, and 30 plus negative 60 is negative 30 j meters. If I wanted to do, say, b minus a, right? B, it will be b negative 100 minus 20 in the I direction plus negative 60 minus 30 in the j direction, which would be negative 120 I plus negative 90 j meters. And if I wanted to do something like b minus 1/2 of a, that would be, well, b is negative 100 minus 1/2 of a, which is 1/2 of 20, 10, in the I direction, plus negative 60 minus 1/2 of 30 in the j direction. So that would be negative 110 in the I direction plus negative 75 in the j direction meters. And that would give me my x and my y. And then if I want to find r squared, would be negative 110 meters squared plus negative 75 meters squared. And I would take square root of that. R would be 125 meters. This is a negative x and a negative y. So that puts me in the third quadrant. So when I find tan theta, negative 1 of negative 75 all over negative 110, inverse tan of 75 divided by 110 is 34.3, but it's in that third quadrant, so I'm going to add 180 to it. Or it would be 34.3 south of west. But I like the polar heading because I like to take x and y with that. To 14 degrees. So 125 meters at a heading of 214 degrees. So as you can see, the unit vector notation just makes it easier to do the math. It's just easier to do it. It's cleaner, it's prettier, and it takes up less room on your paper.